Okay, 29. We've got a table that's basically empty. This looks interesting. I like it. All right. It's kind of a two-factor table, male versus female, left versus right-handedness. We see the total number of students that are left-handed in all is 18, and it tells us here in the word. There are 18 left-handed students, 122 right-hand students, which we see there and there. And they tell us there are 5 times as many right-handed female students as there are left-handed female students. So I'm going to call F females, the number of female students, 5F, 5 times as many as left-handed F. Okay? And they tell us there are 9 times as many right-handed male students as there are left-handed male. So 9, I'll use M as the variable for the number of male students. 9 times the number right-handed as left-handed, which will just be M. So right away, this gives us 2 equations, 2 variables, and we can solve for F and M. Let's just continue reading the problem to see what they want here then once we do that. Which of the following is close to the probability that a right-handed student selected at random is female? Okay, so you want to find out the probability that you get a female given that you're already conditioned on being a right-handed student. Okay, so it's going to be a probability problem. Let's figure out F and M to start. My first equation is going to be F plus M equals 18. My next equation is going to be 5F plus 9M equals 122. Now I want to solve both equations. So what might I do here? I multiply the first one by F, by 5. I'm going to try to cancel on the variable F. So what does that really become? I'll write that in a different color below here. That becomes 5F plus 5M equals 5 times 18, which is 90. So I'm going to subtract that from our second equation. 5S minus 5F cancels. 9M minus 5M is 4M. And 122 minus 90 is 32. So M equals 32 divided by 4, or 8. So there are 8 left-handed male students. We can fill out our table now. It's 8. That means this must be 10. Okay. And 5 times 10 would therefore be 50. And 9 times 8 would be 72. And of course, 50 and 72 adds up to 122, which is our check, basically, of the original equations. Now let's answer the probability problem that's given to us. What's the probability that a right-handed student selected at random, so all my right-hand students are 122 of them. That's going to be my denominator, not the total, but just the right-handed students. My numerator will be the number that are female. That's the condition we want. So the number of female right-handed students is 50 right there. So 50 divided by 122, which is roughly going to be, well, deduct about 20%. It's going to be about 0.4. So it looks like A is going to be the correct answer, 0.41. And I could reduce this if I wanted to as well. That's 25 over 61. I note that that's about 5/12, which is pretty close to 0.4. It's not 0.35, 0.33, or 0.25. The correct answer is A, 0.41. Again, you could use your calculator. Kind of boring, but it might be a touch faster in this case. Okay, 30. 3x plus b equals 5x minus 7. 3y plus c equals 5y minus 7. Yeah, this looks a little more interesting. In the equations above, b and c are constants. If b is or equals c minus a half. So I know b equals c minus 1/2. Which of the following is true? So basically I have to solve for x and as a function of y and a numerical constant. Okay, so this seems pretty strange. I'll then have b, c, x, and y, and in total I only have 3 equations and I have 2 variables. I think this is going to work because I'm solving for one variable in terms of another, so this shouldn't be a problem. Let's go ahead and do that. By the way, I noticed the format looks exactly the same. That looks the same. That looks the same. It's just x's versus y's. So it looks like the relationship of x to y is going to be driven by the relationship from b to c, which they just gave us. So let's try to set it up that way. I know b equals 5x minus 7 minus 3x, which, by the way, is 2x minus 7. And b we know is c minus 1/2. So it's going to be c minus 1/2 equals 2x minus 7. On the other side, I know c, the second equation, equals 5y minus 7y minus 3y. So 5y minus 3y is 2y minus 7. Now the setup looks almost analogous. I'm going to eliminate here. I'm going to subtract my top equation from my bottom equation. C minus the half is going to give me plus 1/2. The c minus c cancels. The minus 7 minus 7, that cancels out. And I get 2y minus the 2x. Okay? So that's really 2 times y minus x equals 1/2. I'm going to divide through by 2 on both sides. 1/4 equals y minus x. So remember, we have to solve for x here. So let's add x to both sides. X, and I'm going to subtract 1/4 from both sides, equals y minus 1/4. The correct answer for x is y minus 1/4. A is the correct answer.